So let's do some descriptive analysis on SPSS. So we have our data imputed, we say analyze, and then we come to descriptive and we say frequency. Okay, let's say we want to see the frequency for gender and would like it to display as a pie chart. We say okay, okay. So this is the output view. So it tells us that female 16, male 14, the percentage is given 46.7, 53.3. You can see this, it gives us the pie chart. So here you can do anything with this analyze. You can do any kind of analysis, you can do your descriptive analysis. Let's say we want to check for the mode. Let's say mean, median, mode, standard deviation, and variance. Let's see what happens. Great. So it gives it, can you see this table? Mean 1.53. What does 1.52 tells us? That 1.53 is almost 2. So this tells us that there are more females than male. And then median 2, mode 2. So standard deviation 0.57, variance 0.257. So SPSS helps you calculate all this without you doing it with a calculator or doing it manually. How about inferential statistics? Let's run some inferential statistics. So what are some statistics that can be called inferential statistics? We have like the independent t-test and the Pearson product correlation. So we go back to our data. Let's say we want to see if there is some if there's a difference in gender, okay, with respect to, what do I want to see? If there's a difference in gender, or let's say if genders, if the response of male and female towards this question is actually different. Remember the M1 question was I feel excited to resume school. So let's see if the response from male is significantly different from the response from the females. Like if there's a significant difference between the two, the response of the two genders. Let's go to analyze. And then we go to compare mean. Remember that t-test is used to make comparison. So there are two independent samples here. So I call it the independent sample t-test. What variable are we testing? We're testing the feelings of excitement. And how are we grouping them? We want to see if there's a significant difference in the gender. So our grouping variable, the groups we want to define are the gender. Let's define our group. Group 1, let's say the first group is for male. So male is coded 1, right? The second group is for female. Female is coded 2. And here's a, okay, we say continue. We can come to option to define your confidence level. Let's say we enter this data with some level of 95%. I can change this to 99 if I want. I can change it to 90 if I want. But let's use the standard, which is 95. And I say okay. Let's see the result it gives us. Great. So in terms of feeling of excitement, we had responses from 14 male, 15 females. And these are the descriptive for the respondents. But we are concerned about the result. So the independent sample t-test gives you Levin's test of equality of variances. So we are interested in knowing whether there's a significant difference, right? This test tells you, is there a significant difference? So can you see this? This is significant. Why is it significant? Recall that we taught in earlier classes that you are measuring your significant value or your probability value against the error margin. That is 5%, which is 0.05. So this is lower than 0.05. If there was a hypothesis that stated that the null hypothesis stated there is no significant difference between the responses of both gender, and then we have the alternative stating there is a significant difference. What is this telling us? This is telling us that there is a significant difference that we should, this is bigger than 0.05. I mean, this is lower than 0.05. So the decision rule is once your significant level, once this is lower than 0.05, you have to reject the null hypothesis. The null hypothesis here states that there is no significant difference between both genders. Here, are we accepting the hypothesis or rejecting it? Because it is lower than 0.05, which is our error margin. 0.05 is our error margin because 95% is our confidence level. So we are giving ourselves a 5% error level. 0.00 is lower than 0.05, which is 5%. Therefore, we will reject the null hypothesis. We are rejecting that statement that says there is no significant difference. So what are we accepting? We are now saying that there is a significant difference between both genders. That is, the way female responded to this question is different from the way males responded to the question. So that's how you define this, or that's how you interpret the t-test. But the t-test, you interpret it this way. Okay, so let's try with correlation. Let's say we want to measure the, let's go back to the data. Let's say we want to measure the, whether there's a relationship between um, the gender and the location. Is there a significant relationship between between gender and where between the gender of the students and where they are residing? Is it that males prefer to be in rural areas or males prefer to be in urban, things like that. So once you say that there's a relationship between the gender and their location, so these are the two variables here, relationship between these two. What do? We still come to analyze and say correlate. We say bivariate, and now these are the two we want to examine, and we want to use Pearson for that. If you come to the option, there are other things. If you want to see the mean deviation, there are other things you can do, but we're just doing a basic inferential statistics. Great. So what does this tell us? What does this tell us? Here we have gender correlating against gender is 1. Now gender correlating with location gives us 0.236. Remember that the correlation R, this correlation, is expressed in percentage, although it comes up as a decimal. When you want to interpret it, you interpret it as a percentage. So this tells us that the relationship between the gender and where the students are residing is 23.6%. If you change 0.236 to percentage, it gives you 23.6%. So what does this tell us? It's a weak relationship, right? I mean, it's not up to 50. So yes, it's a weak relationship such that gender, yeah, the relationship between gender and location is not so strong. But is it significant? That relationship, even though it's weak, is it significant? We look at this. Now this is 0.209. So you ask yourself, is this bigger than 0.05 or is this smaller than 0.05? Obviously, this is bigger than 0.05. So when your significant level is bigger than your error margin, I take that again, when your significant level, which is 0.209 here, is bigger than your error margin, you are going to accept the null hypothesis. We are accepting the null, or we are accepting the negative hypothesis. What's the negative hypothesis? That there's no significant relationship between gender and location. The alternative hypothesis says there is a significant relationship between gender and location. So here is it is bigger than 0.05, which means we are accepting the null hypothesis. Therefore, our conclusion is that there is no significant relationship between the gender and where they are residing, that's the location. And of course, I mean, the students can be in any place, right? So there's really no relationship between those two. So the n tells us the sample size that was used for this. You can see 30. So 30 was the size that was used for this analysis. 30 people responded to this. That's what this is telling us. Okay, if you want to run a regression, let's say you want to regress. I want to do a linear regression. There are different, remember we said there are different types of regression. So let's say we want to use a linear regression and want to see how the effect of the age of the people on the age of the student on the feeling of excitement. So age is independent. We want to see how the age of the student, if it's significantly affected. I mean, if the feelings of excitement, if it's that they feel excited, because of their age level too. If the feelings of excitement is affected by the age. Sometimes they say when people get older, they get more mature, so somehow they're not very excited about certain things. So let's see. Is age Does age significantly affect the feelings of excitement of the student? Let's see what happens. You can plot anything you want here. So this is all this. You have different, if you want to check for the Watson serial correlation, you can tick it. All you just need to do is tick, tick, tick. I mean, collinearity diagnostics, you want to check, you tick it. They are just awesome things you can do with the SPSS if you want. The plots, if you want to see the histogram or normal probability plot, you can see that there. If you want to do other things like this, Mahalanobis is one of the data cleaning technique. Okay, so there are different things you can do here actually. But yeah, let's just do a simple regression. Great. So this is a regression. Remember our objective was to see whether age significantly affects the feelings of excitement. What's the predictor? Age. Can you see that? So it gives us the R. The R tells us the percentage of the relationship between this R is still correlation R. It tells us the percentage of the relationship between age and feelings of excitement. So this is the correlation R. Let's try and see. Let's do a correlation with that. Let's just check to see if we're sure. Analyze, correlate, bivariate, and then we say age and feelings of excitement, right? We just want to check if we are correct with the age and feeling of excitement, and we say this. Great. Can you see? 51.7. 51.7. So it's a negative sign, which tells us that there's a negative relationship, which means as people get older, their excitement drops. So that's the relationship. When you see the minus, it tells you that the relationship is inverse. It's not a direct relationship. It's not a positive one. It's not going in the same direction. So let's come back to our regression analysis. So this gives us the correlation R that age is related to the feelings of excitement by 51.7%. And then the R square is like when every other thing, when the model takes care of other factors that could have affected it, what's the real thing? Then the adjusted R square, for like those in the economics, they work more with the adjusted R square. But the R square and the adjusted R square is fine. You can use anyone to interpret. But there's something about the rule of regression. The R is always bigger than the R square, and then the adjusted R square is always smaller than the, so it goes in this form. This can never be bigger than this. So if you have a regression result where this is bigger than this, then it's fake. Okay. So the adjusted R square is telling us that when every other extraneous variable, when every other thing that could have affected, when all other factors, all other direct or indirect effects, that could have happened in this regression has been taken care of. This is the actual relationship, this is the actual effect that age has on feelings of excitement. 21.4%. 21.4%. So it's not up to 50%, yes. So it's quite a weak relationship or a weak effect. But is it significant? You come to your ANOVA to see this sig value. You can see here the dependent variable is the feelings of excitement, the predictor is the age. So this sig value, 0.003, is smaller than 0.05. When your seek value is lower than your error margin, you are going to reject the null hypothesis. So the null hypothesis here states that age does not have a significant effect on feelings of excitement, while the alternative hypothesis states that age has a significant effect on feelings of excitement. So here tells us I'm smaller than 0.05. Reject the null hypothesis. So we reject the null hypothesis and then we conclude that age has significant effect on the feelings of excitement. Now, effect that effect can be positive, it can be negative. I mean, we know that age has significant effect on feelings of excitement. So is it a positive effect such that as I grow older, I am more excited? Or as I grow older, is it a negative effect such that as I grow older, I am less excited? Let's see. The t value, you can find that in your coefficient. So the t value gives you that option or gives you the idea or helps you to know whether it is negative or positive. So can you see this age down here? We are interested in this column that's called minus 3.196. So for this t value, we want to know, all we're interested in is the modulus, the sign, minus. So this tells us negative already. So this tells us that this is significant. This is significant, yes, but now this is negative. So how do we put this? We now say there is a significant negative effect of age on feelings of excitement. Or we can put it this way, that age significantly affects feelings of excitement negatively. That is to say, as people get older, the feelings of excitement reduces. So that's what the negative thing does. But if there was no negative sign here and this was positive, if this was just 3.196 without a negative sign, it would have meant that there's a significant positive effect of age on feelings of excitement, such that as people get older, they are more excited. Like as this goes up, this goes up. But for negative, it means as the predictor goes up, the dependent drops or reduces or go down. So that's it. We hope that this lesson helps helps you. So data analysis is a different aspect entirely. There are other things you can do, or if you want to take build a career in data analysis with SPSS, there are other things you need to know beyond these basics. But we hope that these basics helps you to learn how to code. Learn how to enter data, learn how to code the data, and learn how to interpret the basic output of data. Thank you so much for listening.